Hello students, good morning all. Welcome back to mathematics class of standard 6. This is the part 4 video of playing with numbers. In previous session you have got to know what is meant by a factor and multiple. Along with that we have done few interactive activities and also we have solved the exercise problem. In today's session you will be getting to know about prime number, composite number, sieve of Eratosthenes, and we will be solving the exercise problem. Now let's move on to the session. Prime number. The number other than 1 which has the factor as 1 and the number itself is called as the prime number. For example, we'll take a number 5. 1 and 5. Other than this, is there any other table does the number 5 comes? No, right? The number which has the factor of 1 and the number itself is called as the prime number. Then what is composite number? Let's get to know now what is composite number. The numbers having more than 2 factors are called as composite number. For example, we'll take the number 6. Write the factors of 6. 1, 2, 3, 6. So, these are the factors of 6. So, a number which has more than 2 factors are called as the composite numbers. Now, let's get to know what is mean by sieve of Eratosthenes. Before getting to know about what is mean by sieve of Eratosthenes, let us get to know what is mean by even numbers. The numbers that can be exactly divided by 2 is called as even numbers. For example, we'll take a number 18. Let us divide this number and get to know whether this is an even number or odd number. So, how many times does the number 18 comes in 2 table? 9 times. So, this 18 is an even number which is exactly divided by 2. Then what is odd number then? For example, we'll take a number 9. An odd number is a number which cannot be divided into 2 equal groups. Can we divide this into 2 equal groups? No, right? So, the numbers that cannot be divided exactly into 2 equal groups are called as the odd numbers. So, students, you have got to know what is meant by prime number, composite number. The number 1 is not a composite number or prime number. A prime number which should have 1 and the number as factor. Here the number is also 1 and the factor is also 1. So 1 is not a prime number. Why 1 is not a composite number? I told you a composite number should have more than 2 factors. So here you see 1 into 1 equal to 1. So, the number 1 is not a composite number. Other than one table, there is no other tables. The number 1 comes is neither a prime number nor a composite number. Now, let's get to know sieve of Eratosthenes. Eratosthenes is a Greek mathematician. He made a method to find the prime number and the composite number in an easier way. I told you that 1 is not a prime number or composite number. So, circle it and cross it. Then, circle 2, cross the multiples of 2. Cross the multiples or the numbers that are exactly divisible by 2. For example, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. I'll be doing up to 50. Along with me, you are going to take your rough note, pencil, and you're going to make a table like this and you're going to solve along with me. First, what I did, I crossed out the number 1 because 1 is not a prime number or a composite number. The next number is 2. I have circled the number 2. Then what I did is, I crossed the numbers which are exactly divisible by 2. Number is 3. As I circle the number, what I'm going to do is the next step, I'm going to cross out the numbers that are being exactly divisible by that number. So 3, 9. 9 is the exact divisible number of 3. 15. We have already crossed out the number 18, so skip that number. The next divisible number by 3 is 21. 24 we have already done. The next divisible number by 3 is 27. Then 33, 39, 42 we have already crossed out, so need not cross out the number 42. The next divisible number by 3 is 45 and 48. 48 we have done already. Up to 50 only I will be doing, students. So you will be doing up to the number 100. Now I have circled the number 5. We are going to find out the exact divisors of 5 and we are going to cross it. 10, 15, 20, 25, 30 is been already crossed, 35, 40. 40 is already striked, 45, 50 is already striked. So these are the numbers that are being exactly divisible by 5. Now let's see for 7. 14, 21, 28, 35, 42, 49. So these are the numbers that have been exactly divisible by the number 7. So here 2, 3, 5, 7 are the prime numbers. The striked out numbers are the composite numbers. The prime number which has the factor as 1 and the number itself. For example, if it is of a 7, so the prime number has the factor of 1 and the number itself. Whereas the composite number 6 has the factors as 2, 1, 2, 3 and 6, which has more than 2 factors are called as composite number. So in this same method only, you are going to circle the numbers and you are going to strike out the multiples of them. Until you reach the number 100, you are going to solve it, students. Now let's solve the exercise problem. Exercise 3.2. The first sum, what is the sum of any two odd numbers and even numbers? Odd number that cannot be exactly divided into two parts. The number, for example, we'll take a number 9 and the second number is 7. When we add these two numbers, we'll check what is the sum of it. So 9 plus 7 is 16. Even number 8 and 6. So an even number is a number which exactly divisible by 2 and it can be easily divided into two parts. The even number is a number which can be easily divided into two groups, whereas the odd number cannot be divided into exactly two groups. So 8 plus 16 is 14. Let's solve the second problem. Second problem, state whether the following statements are true or false. First statement, the sum of three odd number is even. Let's check with an example. 3 plus 5 plus 7. So 3 plus 7 is 10. 10 plus 5 is 15. The statement sum of three odd number is even is false. Second statement, the sum of two odd number and one even number is even. Let's check with an example. 5 and 9 are the odd number. Along with that, we are going to add one more even number to that. So we'll take an even number as 4. 5 plus 4 is 9. 9 plus 9 is 18. So the statement the sum of two odd number and one even number is even is true. Third statement, the product of three odd number is odd. I have taken three odd numbers. Now let's check their product whether it is of a odd number or not. First, let us find the product of these two numbers. Then with that answer, we will multiply 9 and get to know whether the product of three numbers are odd number or even number. So 7 3s are 21. 21 into 9 is equal to 189. So the product of three odd numbers is odd. So the statement is true. Fourth statement, if an even number is divided by 2, the quotient is always odd. So let's get to know whether the statement is true or false. Case 1. Let's take the first number as 4. 4 divided 2. So 2 2s are 4. So case 1, it is false. 4 is an even number. When it is divided with 2, the quotient is even number. So in case 1, the statement is false. Let's check with the second case. Case 2. 18 divided by 2. 2 9s are 18. So here the quotient is odd number. This satisfies the statement, but what they have given in the statement is, if an even number is divided by 2, the quotient is always odd. Quotient might be also even number. So the given statement is false. Fifth statement, all prime number are odd number. Let's check whether the prime number are only odd number. The prime number starts from 2, 3, 5, 7, 11, 13 and so on. So see here, the first number itself is an even number. The statement all prime number are odd is false. The rest of the statement is your homework, students. Now let's solve the third problem. The numbers 13 and 31 are the prime number. Both these numbers have same digits 1 and 3. See here, 13 and 31 have the same digits 1 and 3. So what they have asked us to find out is, they have asked us to find out the same pair of prime number which has the same numbers, which is up to 100. Solution: 17 is a prime number and 71 are the prime number which is of the same digit 15 and 51. No, right? Why? Because 15 is a composite number. So 15 and 51 will not be a prime number. 7 and 72? No, right? Why? Because 27 is a composite number, whereas 72 is also a composite number. Let's check with 37 and 73. Yes, 37 is a prime number and 73 is also a prime number. You are going to find out the next pair which is of a prime number and which has the same digit. Fourth problem, write down separately the prime and composite number that is less than 20. So we are going to write the prime and composite numbers which is less than 20. 2, 3, 5, 7, 11, 13, 17 and 19. So these are the prime numbers which are less than 20. Let us find out the composite number which is less than 20. 4, 6, 8, 9, 12, 14, 15, 16, 18. So these are all the composite number which is less than 20. Let's solve the fifth problem. What is the greatest prime number between 1 and 10? So in previous problem itself we have written the prime numbers which is less than 20. From that itself I am displaying the numbers which are between 1 and 10. 2, 3, 5 and 7. So these are the numbers which are between 1 and 10. Among this, 7 is the greatest number. So therefore 7 is the greatest prime number between 1 and 10. Sixth problem, express the following as the sum of two odd prime number. I will be solving the first two problems. The next two problems is your homework, students. Let us express the number as the sum of two odd prime number. 3 is an odd number and it is also the prime number. 41 is an odd number and it is a prime number. When we add this two, we get the sum as 44. 7 is an odd number and it is also the prime number plus 37. 37 is also an odd number, along with that it is a prime number. The prime number which has 1 and the number itself as a factor. So 37 is a prime number. So when we add this two, we get the sum as 44. Let's do for the next problem 36. 31 is a prime number and 5 is a prime number. When we add this two odd prime numbers, we get the sum as 36. Similarly, 29 is a prime number plus 7. 7 is also a odd prime number. When we add this two, we get the sum as 36. This is all about today's class, students. Until we meet in next class, keep practicing the problems that have been taught to you.